Hi everyone, my name is Ken Finnegan. Today I'll be talking to you about the OpenTelemetry Collector. But first, let's start by giving a quick overview of what OpenTelemetry is, which can also be referred to as OTel as shorthand. So OpenTelemetry is a vendor-neutral open source collection of projects for instrumenting applications or services to generate telemetry data, collecting telemetry data from a variety of sources, and finally exporting telemetry data to your preferred observability vendor or other storage location. The only part of OpenTelemetry the collector is not involved with is the instrumentation of applications or services. I won't be covering OpenTelemetry in detail today, as there are many resources available that cover all the components of OTel, which are not related to the collector. So feel free to go find those yourself and research those aspects. So let's kind of get on to what is the OpenTelemetry Collector? Why should I care? So the OpenTelemetry Collector is a pipeline for processing telemetry data. That's it in a nutshell. There are various different parts that make up that pipeline and what we can add to that pipeline, and we'll be covering those shortly. So the first question to answer is, why would we use a telemetry pipeline? And what value do we get by having one? Though a service can send telemetry data directly to an observability backend or other kind of storage, this increases overhead on the service for the compute and memory that it requires to ensure that that telemetry data it's generating from its own self is delivered to that final destination. When we talk about resiliency, we kind of want services to gracefully handle any disruptions in that network connection to that storage or final destination. That requires them to have a level of memory to store this telemetry data internally in the process before sending it to its final destination. And there may be a level of retries that it wants to perform as part of that as well. That's a lot of work for a service to do in addition to handling our customer requests. So we want to offload that telemetry data out of our service as quickly and reliably as we can. Having an OTel collector deployed alongside the service can do that for us. The collector also helps us associate common attributes on all telemetry, transforming them in some way, removing unneeded attributes, and many other types of processing on the telemetry data itself as it passes through the pipeline that we may want to perform to clean up, aggregate, or add additional information. So when it comes to how we can deploy the OpenTelemetry Collector, there are a few things we need to consider. The architectural pattern we want for our system, and the deployment modes that the OTel Collector offers us. So there are several architectural patterns that we can utilize when incorporating the OpenTelemetry Collector. The first is just the application talking directly to the observability backend, as we kind of described as the thing we don't want to do. This is a situation where we don't have any OpenTelemetry Collector in place, and it sends data directly to the backend. This is the scenario where we have a lot of overhead added by doing this, and it's preferably not one that we want to do. The first kind of viable deployment option we have that we want to consider would be an agent pattern, where the OTel collector is deployed alongside our services. Now, with the agent pattern, there are two different deployment modes available. One is as a sidecar, which is what is seen here, where the OpenTelemetry collector is running in the same pod as the application. Another option that we have is to deploy it as a daemon set. And this means that there will be a separate OpenTelemetry collector on every node within our cluster, and each one will send directly to the observability backend. Now, which approach of those you might prefer can depend on the load your applications are generating, as well as the pod density on each node. So if you have an application that produces an extremely high amount of telemetry data, you may prefer to process it all through its own OpenTelemetry Collector deployed as a sidecar. This will prevent the telemetry from one service overloading a single instance of the collector that's trying to handle telemetry from many services. Another approach is when you have a low number of nodes but high number of pods, you could prefer the sidecar deployment to prevent overloading a single collector from trying to handle the telemetry of too many different services. Another option we have here is the gateway pattern. This pattern, as we can see here, allows us to deploy a single instance of the OpenTelemetry Collector on whichever node Kubernetes decides to deploy it on. And then all our services or applications are sending their telemetry data to that one collector instance. And then it will send and batch up that data and send it to a single backend for observability or storage. So this deployment is a deployment type or stateful set deployment if there is some particular state in the OpenTelemetry Collector we need. And lastly, we have an option of a layered pattern, where we have two layers of collectors within our cluster. This pattern is useful for use cases where we want to process similar data in a specific group of collector instances every time. So this layout, it requires us to have an initial OpenTelemetry Collector at the point that receives telemetry from services, and then it will load balance across other sets of collector instances to ensure that the same pattern that is required always gets processed by the same set of second layer collector instances. Now, this is required for situations where you want to implement tail-based sampling, or situations of wanting to process all telemetry data, for example, logs, from a given service in a particular location, so you can add like rate limiting to that service. We can handle load with this by scaling the load balancers at the front, but also scaling the collectors in each group that we're sending to. And we can also combine patterns together. So in this pattern, we're combining the agent and gateway patterns. So we have a OpenTelemetry Collector on every node acting as the agent, where the applications will send their telemetry data. And then we have a deployment within the cluster that acts as the gateway. And all the individual agent collectors will send their telemetry to that gateway, and then the gateway will send everything onto the observability backend. So when we're thinking about patterns for deploying the OpenTelemetry Collector, we need to have an understanding of what telemetry data we want to collect, as the specific telemetry we want to collect will determine the pattern we must use to collect it. So, for example, if we want to collect the Kubernetes events from a cluster, we need the gateway pattern or even just a single deployment to ensure that we don't capture the same Kubernetes event multiple times from different collector instances, which is what would happen if we were trying to collect Kubernetes events when it's deployed in agent mode. This is not what we want. And the same situation applies if we were wanting to utilize like kubestate metrics to retrieve the metrics from Kubernetes itself. We want to capture that only once in a cluster, not for every node in that cluster. But on the other hand, when we want logs from all the nodes in a cluster, we need the agent pattern to collect logs from each of those nodes. If we only deploy a gateway collector, then it's only going to be able to collect the logs from the node it's actually running on, which is fine if you only have one node in the cluster. But if you have multiple nodes, then you're not going to be collecting all the logs. Which pattern or combination of patterns you want to use with the collector depends on which telemetry you want to capture, the scale you need to be able to handle, and the level of resiliency you want in your collector architecture. And that kind of comes also into a decision of what is the comfort level of your team when it comes to their experience with managing OpenTelemetry Collector deployments. Too much complexity for a team, especially all at once, can add undue burdens on them making sure everything's running the way you want it to. Let's move on to talking about the different components within a collector itself. So I mentioned previously that each collector consists of pipeline. We can configure at least one pipeline. In this case, we have a logs pipeline that will receive data and send it out. We're also able to define multiple pipelines within a collector. And typically the pattern we have is that you would have a separate pipeline for each type of telemetry data, as there will be specific processing you may want to do that is only applicable to a specific telemetry type. So this allows us to run multiple pipelines. And we can also have multiple pipelines of the same telemetry type if there's different places we need to collect that log, for example, from, and do different things depending on where we've gotten it from. So each pipeline itself has several components that are configured within it to actually do the work. First, we need a way to get that telemetry data into a pipeline. This is done by receivers. Depending on the specific receiver in a pipeline, it will either receive data, push to it from outside the pipeline, or it will go and fetch data and bring it in itself. So for example, here we have defined a Kubernetes objects receiver. This particular receiver will access the Kubernetes API to retrieve the objects from Kubernetes and then pull them into the pipeline for processing. However, like the OTLP receiver, which is the format for OpenTelemetry, will open an HTTP and or gRPC port, depending on your configuration, to receive data sent to it. Depending on the pipeline, you may only have one receiver, but it's also possible to have multiple. So here we have a file log receiver, which reads logs from nodes, and we have an OTLP receiver, which could receive traces, metrics, or anything else sent from applications, for example. If you have different locations we want to get logs from, but process them all in the same way, we can use multiple receivers in a single pipeline to achieve this. Now, with the data inside the pipeline, we then need to do stuff with it. So what is that? We have processes to act on that data. Now what we have here are the recommended processes from the OpenTelemetry Collector project that you should have, even if you're not doing anything specific yourself. The K8s attributes one I've added as if you're deploying to Kubernetes, you would want this one in there. But it is also totally fine to have no processes at all. They do recommend the memory limit processor to ensure that you're not consuming too much memory within the collector instance itself. Otherwise, you'll potentially open yourself up to crashes of the collector when you're processing too much data and it runs out of memory. The other one that they recommend is the batch processor, which reduces load on the outgoing connections transmitting that data as it performs a level of compression and batching into multiple records in one transmission. So you're not opening a connection to an external location for every single record of telemetry you're processing in that pipeline. And as I mentioned, the K8s attributes processor is added. So for when you're running in Kubernetes, you want that metadata for Kubernetes associated with your telemetry. So pod ID, pod name, node ID, node name, cluster ID, all that kind of information. Now, once we've processed telemetry data in our pipeline, we then need to send it somewhere. So these are the exporters. So in this particular example, we have an OTLP exporter. So it'll export the data after it's done its various processing in the OTLP format and send it wherever you configure it to send. As with receivers, we can have one exporter for a pipeline, or we can have multiple. In this case, we're now also sending the same data to the Kafka exporter. When there are multiple exporters, each destination, so OTLP exporter and the Kafka exporter, will receive the same set of data that passed through the pipeline. This is a great way to try out different observability backends by sending the same data to two different locations to allow you to compare the visualization and functionality of the different systems. Pipelines also have a fairly new component within them called connectors. Now, a connector can act as both an exporter and a receiver. So this allows us to combine pipelines together within the one OpenTelemetry Collector instance. So instead of having two instances running different pipelines that then talk to each other through OTLP, you can run them within the one binary as two separate pipelines. So this particular example here is using the span metrics connector. So we have traces flowing into the collector in the first pipeline. We do some processing on it. We export them with the OTLP exporter to a final destination for traces. But we also use the span metrics connector to feed those traces into a new metrics pipeline. And the connector kind of acts as an exporter in one pipeline and a receiver in the other. And that allows us, in this particular example, to generate metrics from the traces that have been processed by the first pipeline. Another use case for connectors is the routing connector, which allows you to send logs to different locations based on a condition within the logs. So we would have one pipeline that receives the logs with the routing connector as the exporter, and then two child pipelines, which are both logs as well, but they export to different locations. And we use the routing connector to decide which particular logs go to each pipeline. So that's a lot of information and detail there. Let's get into what it actually looks like. So here we have a Docker Compose file for the OpenTelemetry Collector. This is just the base core collector. This is not the contrib with all the extra pieces in it. We can see here we're passing in a config to say we want to use this OTel collector config YAML to define the collector configuration. And we're telling Docker over here that this file that we're going to put into etc. and that name is just the file right over here. We also open up some ports. So we have a gRPC port, a HTTP port, and this is all because we're running in Docker to allow our system to access inside. And we expose the metrics endpoint and also the health check endpoint. So this is the collector config right now. Very straightforward, very simple. At the very beginning, we define our receivers. And we say we have an OTLP receiver, and we want to enable both the gRPC and HTTP protocols, specifying to accept requests from all hosts and to open them on these ports. Here right now we've defined an exporter, which is the no-op, so it basically does nothing. And we have a simple log pipeline defined here, which has the receiver using the OTLP and then the no-op exporter. So let's go see that in action. Now with Docker running for these pieces, I can now run the collector by running docker compose up. And if I hit enter there, we can see the logs from the collector saying that it started and it included the components for the OTLP receiver for gRPC and then the one for HTTP. So that is now running. Now if we go over to another terminal, what we can run over here is use the telemetry generator to actually send a log record to our collector. Now that's a lot of information there. Essentially, it's just sending it across to the collector running on our port. Now, if we go back to our collector, we can see we don't have any information. Nothing has happened since we had it first starting. And that's because we have the no-op receiver installed. So we're not going to see anything in the collector to show that something's happened. So let's go back to the IDE. And what we'll do is add the debug exporter into the pipeline. So we can change this to use debug. And we'll save that. And then we'll go run that. We'll cancel this one. And then we'll run it again. And we'll see here that we've got this handy error that we have invalid configuration for our logs pipeline. It can't find reference to the debug exporter. And it's saying it's not configured. So let's go back to the IDE. And what we need to do is add another entry here for debug. And save that. And then if we run that again, okay, so we've now added the debug exporter into our list. So let's go run that. And now it's running with the debug exporter. So if we go back over to our other terminal and run the generation again, we can see and then go back to our other terminal, we can see in the bottom here that we have a log of it receiving a log record. Now, that doesn't have a lot of information there, so it's not super useful. So let's cancel that. And then we'll go back to our IDE. And then we'll increase the verbosity of the debug exporter by saying we want detailed. And then if we go back to our terminal and run Docker Compose up again, so we're ready to receive information. And then if we go back and run our telemetry generation again, and if we have a look at where we have Docker running, we'll see there's a lot more information now. So again, we have the same line as before, where we're saying we received a single log record and we processed it. But then there's some extra detail here. So you actually get to see the details of the log record. So here we can see we have a resource attribute of service name, which is set to telemetry gen, because that's what I was using. We have a timestamp of when it was received, severity of info, and we have a body string which says hello exclamation, which is what I sent across. So this is very cool and allows us to see what we're sending to the collector without actually having to have an endpoint that we need to stand up to see logs, for example. Let's come back to the IDE and we'll do something else now. We'll add the ability to see metrics from our collector as a way to show how we can observe and monitor our own collector instance. So this section here says we're enabling the telemetry for metrics, that there will be an exporter for Prometheus that will be open to all hosts, and it'll use port 888, which is one of the ports we exposed on our collector. So we've added our telemetry metrics definition, we've saved the file. Now if we go over to the terminal and run Docker Compose again, and then if we switch to the other window and curl the metrics endpoint, we see all the metrics that are currently in our collector and generated by a collector. Now that's a reasonable amount. If we have a look here, right now there's not anything super interesting. It's got some details about its uptime, the amount of bytes it's been allocated, any errors, etc. What will get interesting is now if we run our generator again to send a message, and then we curl the metrics again, now we have a few more metrics than last time. So the ones of note are, where are they? There we go. We have receiver accepted log records total. So this is how many log records the receiver has received, and it's a counter, and right now it's received 1. And it has some details about where it received it from as well. And then we have a count of any refused logs, which at the moment is 0, which is good, as we like to see. Now, if we send a couple more requests in, and then run the metrics again, we'll now see we're at a record count of 3, which is what we'd expect to see, which is good. It means everything's working. The internal metrics are generating the data as we expect, and our log pipeline is working and taking data from the input, processing it, and sending it to the output. That's all I wanted to show you today. So thank you for taking the time to watch, and I look forward to seeing you again soon.